Last episode, we got tokens into vectors and stamped them with position. Now, those vectors hit the one operation that defines a transformer, attention. And the cleanest way to understand it is this. Attention is a dictionary lookup, but a soft one. Let me show you what that means. 3 roles, 1 per token. The query is the question this token is asking. The key is what each token advertises about itself. The value is what each token would contribute if you pick it. Query key value, QKV. The model produces all 3 from the same input vector using 3 learned weight matrices. Here's the lookup. Take one token's query and compare it against every token's key. That comparison is just a dot product, and a big dot product means a strong match. Do that for every pair, and you get a grid of scores. Every token scored against every token. That grid is the heart of attention. And it's also why attention is expensive, because it grows with the square of the sentence length. Turn the scores into weights with softmax, so each row adds up to 1. Now they're proportions. Then take a weighted blend of everyone's values using those proportions. A token that matched strongly contributes a lot, a weak match contributes a little. The output is that blend, the token's new representation, now aware of its context. But there's a detail in the scoring. We divide by the square root of the head size first. Skip that and the scores get huge. Softmax snaps to all or nothing and training stalls. The scaling keeps it gentle. One more rule for generation. A model writing text left to right must not peek at the future. So before softmax, we mask the future out. Set those scores to negative infinity, which softmax turns into exactly 0 weight. On the grid, it's a clean triangle. Each token sees only itself and what came before. That's the causal mask, and it's what makes next token prediction honest. And a quick contrast, when the query's keys and values all come from one sentence, that's self-attention. When the queries come from one place and the keys and values from another, like a translator looking back at the source, that's cross-attention. Let's build the picture. Bottom, a short sentence in word boxes. From each we'll grow a query, a key, and a value. 3 projections. Every word's vector goes through 3 learned matrices and becomes a Q, a K, and a V. Blue for Q and K, the question and the advertisement. Gold for V, what gets contributed. Now the grid, take each query, dot it against every key, scale by 1 over root D, light up the T by T score, matrix cell by cell. Bright cells are strong matches. This grid is the quadratic cost everyone worries about. Drop the causal mask on top. The upper triangle goes dark, set to negative infinity. Each row now only reaches the diagonal and to its left. Then softmax each row. The lit cells become weights that sum to 1. Finally, each row's weights blend the value vectors into one output vector. The gold arrows pulling weighted values down into a new representation per token. That's one attention head, start to finish. Off to the side, the pink variant, cross attention, where the queries come from the decoder and the keys and values come from an encoder. That's how translation models look back at the source. Next episode, we stop drawing and build this scaled dot product attention from scratch in about a dozen lines of PyTorch. Then the one line fast path NVIDIA GPUs actually run. Last note, B4 carries the teaser to NV10. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.